Today I'm going to be talking about measuring and constructing angles. Now the first thing that we have to go over is how to classify an angle. You probably already have learned this, so this is just a basic review. An acute angle is going to be less than 90 degrees. An example is like that. An obtuse is in between 90 and 180. And it would look something like this. Then we've got our right angle, which is 90 degrees. And don't forget, there's always that symbol in the corner, a kind of half box to indicate that it's right. And our very last one is a straight angle, which is a line, which is 180 degrees. And a way I remember this is if you can draw a half circle, it's 180 degrees because a whole circle is 360 and half of a circle is 180 degrees. So if I can draw a half circle, I know that the measurement of that angle is 180 degrees. Next, we have to learn how to name an angle properly. Now, we have the vertex, which is the middle of this angle. And the vertex always has to be in the middle of the name. So we can start at K and we can trace with our finger. Here, let's use a highlighter to trace this. So we can trace from K to J to L. So we can name this angle KJL. And we also can go the opposite way. We can go from L to J to K. And if you notice, J, the vertex, the middle point of that angle is always in the middle. So we have to be able to properly name that. Now, we also have a third name for this, and if it's standing on its own, like this picture right here, we can just name it J. But very few times is it standing alone, so we usually use the two above it. Okay. Now we have a protractor with a few lines and angles on here, and we are going to find the measurement. That's what the little m means. Find the measurement of angle GHK. What I like to do is I like to trace it so I can make sure I'm getting the right angle. So I go from G to H to K. Okay. Now if we look at this, this is an obtuse angle, and we have two options. We have the smaller numbers and we have the larger numbers. And since it's an obtuse angle, we're going to do the larger numbers. We're going to look at the larger numbers. And since it's in between 120 and 130, this is going to be about 125 degrees. So that's how we use that protractor. Okay, let's do JHL. So we go from J to H to L. And if you notice, it's straight up at the 90. It's a right angle, so it's 90 degrees. All right. And our very last one is LHK. L to H to K. Now this one is a little bit trickier because we don't have it sitting at the 0. So this one we have two options. We either can count the amount that's in between the two green lines, or we can subtract the numbers, okay? So we can do 125 minus 90, or we can count 10, 20, 30, and then 5 ticks. So that's 35 degrees. So we either can subtract or we can count, either by 5s or 10s. And people prefer counting, but we also can subtract. It's really easy. All right. Let's talk about the angle addition postulate. Now, the angle addition postulate is very similar to the segment addition postulate. And the segment addition postulate and the angle addition postulate has the same concept. We can take a part plus a part, and it will equal the whole thing. Part plus part equals whole. So we can use that looking at number 1. I ask you to find the measure of DAB, and let's outline it to see what we have here. So DAB is the whole angle. So what we can do is we can take the two parts and add them together. And we get 47 degrees. Part plus part equals whole. Make sure we have the degree symbol on there. Now this next one is a little bit different. This one I gave you a part, which is 22 degrees, but I also give you the measurement of FEH. And FEH is the whole thing, which is 85 degrees. I like to write it on the outside so I know that's the whole thing. Now if I have a whole and a part, we can subtract We can do 85 minus 22 degrees. We can subtract to get the other piece, the HEG. Okay? So we get for this one 63 degrees. Now we've added a little bit of algebra, okay? I've given you MLL, the measure of MLL, which is the whole thing. So I'm going to write 145. And we can still use the part plus part equals whole concept. All right, part plus part equals whole. Now we have the two parts and we have the whole. One part is 2x plus 10. The other parts, we add it to the other part, which is 4x minus 3. And we set it equal to the whole, which is 145. So the part plus part equals whole is kind of like a formula where we can plug in our information. So we have our 2x plus 10 plus 4x minus 3 equals our 145. Now all we have to do is solve our algebra problem. And this one is where we have to combine like terms. I like to say circle your friends. So we have a 2x and a 4x, so that gives us a 6x. We combine like terms because it's on the same side. And then we have a 10 and a negative 3, which gives us a positive 7. And that equals 145. Then I'm going to subtract my 7. And I get 6x equals 138. And then I divide by 6. So our x for this problem is going to be 23. Now, since we found x equals 23, we can go back and find MON. Well, MON is right here in this green piece, and the expression for this is 2x plus 10. So what we can do is we can plug in 23 for this. Okay, this is going to be 46 plus 10. So we get 56 degrees for MON. And you guys are used to the plugging in because we did that before with segments. All right. Now let's talk about supplementary and complementary angles. Supplementary angles are two angles added together and they equal 180 degrees. Complementary is when you take two angles and add them together and they equal 90 degrees. So if we look at these two pictures, we have to determine, are they supplementary or are they complementary? So if we look at number 1, if you notice that KLM is a straight line. And remember when I said a straight line was 180 degrees. So number 1 is supplementary. So we can just visually see that it's supplementary because those two angles make up a straight line, which is 180 degrees. So we can use our part plus part equals whole. And solve this problem for x. So our part is 10x minus 5 plus 4x plus 3, our other part, and our whole thing for this is 180. Since it is a supplementary, since it's supplementary angles, it's going to equal 180 degrees. So now all we have to do is combine like terms. 10x and 4x is 14x, and negative 5 and 3 is a negative 2. We add the 2. 14x equals 182. Divide by 14. And you get 13. We didn't have to solve for any angles. I didn't ask for that. So just solving for x is fine here. Now if we look at number 2, we see that red box that indicates 90 degrees. So we know this is a complementary angle pair. So we can set this up using our part plus part equals whole. So we can do 2x plus 2 plus x plus 1 equals 90 degrees, since they both make up 90 degrees. So we can combine like terms. 2x and x is a 3x, and 2 and 1 is 3. Subtract our 3. 3x equals 87. Divide by our 3. And x will equal 29. All right, so that's supplementary and complementary. Next up, we're talking about an angle bisector. And I tell you that AB bisects angle DAC. AB bisects angle DAC. And if we think back to a couple of sections ago, I talked about a bisector. And I said that a bisector cuts something into two equal parts. So whenever I see bisects, I can automatically think equal because it cuts it into two equal parts. So that's your keyword. Okay, so number one tells us that the measure of DAB is 21 degrees. So I'm going to outline DAB and label it 21 degrees, okay? Now I'm going to find BAC, the measure of BAC, which is right next to it. Now if one of the angles is 21 degrees and we have an angle bisector, the other one has to be 21 degrees since they are equal parts. So the measure of BAC is 21 degrees. And next we have to find the measure of DAC. Well, DAC is the whole thing, so we can add 21 and 21 and get 42 degrees for the whole thing, for the measure of DAC. So now let's add a little algebra into this, okay? I tell you that AB, right, AB bisects angle DAC, and when we see bisect, we can think of equal. Okay, and this time I don't give you any measurements at all. I just give you two expressions. But if we know that AB is the bisector, then these two pieces are equal to each other. So we can set an equation saying 3x plus 6 equals 7x minus 18. We can set them equal since AB is the bisector. So now let's solve. Let's subtract that 3x. 6 equals 4x minus 18. Add our 18. 24 equals 4x. Divide by 4. We have x equals 6.